Hi, welcome back. Now we're going to begin to talk about pointers. And pointers are going to occupy quite a bit of our time in the C language. If you have heard of pointers and you're beginning to panic, don't. They're not difficult. They're just different. If you have never heard of pointers, don't worry about it. It's not that hard. A pointer is simply a variable, any kind of variable, that contains the memory address of another variable. That's all it is. Two operators are used when we talk about pointers. There is an ampersand, a single ampersand. This is called the address of operator. And there is the asterisk. This is called the contents of, or sometimes it's called the indirection operator. So what does that mean? Well, the address of operator takes the address of whatever we tell it to. The contents of operator gets the contents in memory at that address. So let's say A is a variable, any kind of variable. Address of A becomes a pointer to that variable. So a pointer is simply an address. It's an address in memory to a variable. So address of A is a pointer to that variable, the address of A. If PA is a pointer to A, then contents of PA is the value stored in A, the contents of A. So how do we use pointers? Well, simply, we declare a pointer by assigning the address of a variable to the contents of the pointer. So here we have an integer A. It can store any int value, 4 bytes. Now we have an int star PA. This is the contents of PA becomes the address of A. So we declare a pointer by using the contents of operator. Int star, char star, float star, double star. We get the value stored in the address by taking the contents of the pointer then. So suppose we want to assign whatever is in A to a new integer B. So int B equals the contents of PA, assuming that PA was already stored the address of A. This is the same as saying B equals A. In other words, the value of B becomes the value of A. Slightly different here because the value of B is becoming the contents of a pointer to A, but really the same. We can store a new value into a variable by using its pointer. So we can store a new value by assigning to the contents of the pointer. Contents of PA is 35. That's the same as saying A equals 35. However, if we've done all this stuff so far, it is not the same as saying B equals 35. B stays whatever it was before we reassigned PA, or contents of PA, or indeed A. Now, that makes sense. If we just have two variables, A and B, and I make A equal 1, and then I say B equals A, now B equals 1. Now if I say A plus plus, we would assume that B still equals 1, but A now equals 2. However, if I have a variable A and it is assigned the value of 1, and I say contents of PA1 equals the address of A, and contents of PA2 equals the address of A, now if I say A++, both the contents of PA1 and PA2 are 2, because we're pointing to the same location in memory. So let's see if we can't get some kind of intuitive idea of what's going on with pointers and how they work with memory. So here I have a picture, a completely fictitious picture of a bunch of bytes in memory. And we're assuming that this goes on virtually infinitely in the left direction and the right direction. So I'm looking at 7 bytes arbitrarily in memory. Now, suppose I assign or make an int A. What does that do? Well, it grabs a hunk of memory 4 bytes long, makes it an integer. Well, it just grabs a hunk of memory 4 bytes long, and it gives it the label somehow A. And it doesn't assign anything there because I didn't tell it to. So the value of A, variable A, is unknown. So now we just say A equals 42. Now it plugs the integer 42 into those 4 bytes. The next thing I want to do is make a pointer to the contents of A. Or in other words, I want to get a variable that is equal to whatever the address of that 4-byte integer is in memory. I do that this way. I call it PA, I make it an integer pointer, and what is its value? Well, it's unknown. So far, we don't know what its value is. We won't know what its value is. Really, we'll never really care much what its value is because it's going to contain an address. It really doesn't make any difference what that address is. We can get the contents of it, but so far it's just int star PA means give me a pointer to an integer. Only when I do the next step and say PA equals now the address of A does that pointer get assigned a value. And the value it gets assigned is the memory address of A, not 42, but whatever the address, whatever the physical address of the first byte of that 4-byte area in memory, the integer is. Then if I then say star PA, contents of PA, that represents the value stored at A. In other words, 42. If I change A to 43, contents of PA changes. But if I change PA to some other value, it's going to point some other place. That's dangerous. We don't want to arbitrarily change the value of a pointer, but we can arbitrarily change the value stored in the address that is pointed to by that pointer. So don't panic. I mean, there's a lot of words here, but if you go through this video a couple of times, you'll see that really the underlying idea is not all that difficult. A pointer is a variable that holds a location in memory. It holds the address of a location in memory, just like the address on an envelope tells the postman where to go on a particular street in a particular town, and so forth. Thank you very much.